All right, hello everyone. I think we're about ready to get started here. Today's webinar will be covering the newest model of Sutron's logging transmitters, the SatLink 3. On our panel today, we have Dan Farrell, Sutron's Chief Technology Officer, and Brent Helstern, Sutron's Water Quantity and Communication Specialist. If you want to get in touch with either panelist after the presentation, I'll have their contact details at the end. Also, we'll have a question and answer session at the end of the presentation. If you have a question, simply type it into the chat box at any time, and I'll ask it during the question and answer. With that, I'll hand the presentation over to Dan.
Hello, everyone. We're excited to present to you Sutron SatLink 3. SatLink 3 is a data logger with a built-in GOES satellite transmitter, and these types of stations are really used all around the world for measuring the levels of streams, agriculture, and even on the tops of mountains, as you see in the picture in the left-hand side. So here's your first look at SatLink 3 up close. One of the first things you'll notice are the terminal strips that we have. On each side there are 5 different separate terminal blocks that make it easy to connect sensors. Having these terminal blocks means you don't need expensive connectors, but can just use bare wires in order to make your sensor connections. One of the most common field problems that people have over the years is connections and connectors. And these terminal blocks really make a very reliable connection and make it possible for you to do those connections in the field. There's a separate connection for the battery power to power the unit. There's a connector up here for the GPS antenna. And then we have a variety of different connections down here at the bottom. This one here is our Wi-Fi reset button. When you come up to a unit, if you wanted to communicate via Wi-Fi, you would just push that button. It would flash blue, and you'd be able to have a Wi-Fi connection. Otherwise, if you have a laptop with a USB port on it, you'll plug right in here to this OTG device. This RS-232 port is for legacy PCs that don't have a USB. You'll plug in your traditional RS-232 cable and communicate with the SatLink 3. And this one here is USB host. It's meant for a memory stick so that you can download data or upload setups to SatLink 3. Here's your main connection for the GOES antenna. And then we have 2 expansion slots built into SatLink 3, and those expansion slots are where you'll plug in your Iridium modem or your cell modem, or over time we'll add additional functionality to SatLink 3 so that it can always stay current with any particular data collection challenge that you might have. So if we were to look at just a summary of the different features that we have built into SatLink 3, we've talked about the removable terminal strips and separate power connections. Here's down here where you have the 2 independent SDI 12 ports. And then over here we're going to have our single-ended analog and differential analog. These differential will be used if anytime you have a high accuracy requirement for a strain gauge, thermocouples, RTDs, or devices like that. SatLink 3 can measure those sensors directly. It has its own signal conditioning built in. So essentially it allows you to use a cheaper sensor in order to have a very accurate measurement. We've built in a 4 to 20 milliamp analog input also. There are a lot of 4 to 20 milliamp sensors out there, and this means you don't need an external load resistor. It's all built into SatLink 3. It's very easy to use. We have 2 frequency counter level inputs, and these will work with tipping buckets or on-off switches or frequency type output wind sensors. And one of them works with the RM Young wind monitor, that low-level AC signal that you have out of it. So basically, with these frequency inputs, we can handle on-off switches, pulsing devices, flow meters, any number of different kinds of digital type inputs. We've got 2 digital outputs. These are nice for turning things on or off. They're nice for triggering a sampler or something that you may want to connect to SatLink 3, and you want SatLink 3 to be able to turn it on or off or pulse it. We have RS-485 input capability. Switched power voltages. These are useful when you have a sensor that uses a lot of power and you want to turn it off between measurements to conserve power. I mentioned the built-in Wi-Fi access point, and that's very useful again for your mobile devices. has an optional display. Of course, the built-in satellite transmitter itself with output capability of 1 to 10 watts and our optional Iridium and cell modems. Then you've got the USB host for a memory stick, USB on-to-go for a PC, and RS-232 for legacy systems. Here's just another view of that functionality with the sensors and different sensors shown here on the left-hand side, and how you can connect to SDI, analog, digital, and RS-485 sensors. The different telemetry options are here over on the right-hand side with the built-in transmitter, optional Iridium, cell phone modem, mesh communications, the built-in GPS for accurate time and location information. And then we have our user interface functionality down here with our Wi-Fi talking to PCs or tablets, memory sticks plugging into USB host, PCs with on-the-go, and other PCs with RS-232. And on the inside, we have just a representation of some of the core pieces in SatLink 3, a real-time clock with battery backup, optional display, a processor with measurement setups, alarms, logs, diagnostics, flash memory, expansion memory, and physical expansion for our option cards. Here's a list of the main tasks that a SatLink 3 performs. And it starts out with its internal clock maintaining accurate time. Everything that SatLink 3 does is synced to a clock, so that if you've told it to collect data at a particular schedule, it will collect at that time. If you told it to transmit, it transmits at that time. So the clock's really important, and it keeps its clock synchronized to GPS. At a schedule that's entered by the user, and I stress you get to put in that schedule, it will make measurements of the sensors that you've configured in the system. And as it makes those measurements, it applies a slope and an offset or does a special calculation as needed, and then stores the data into its non-volatile memory. And that's really the main set of tasks that you configure it to do. You may schedule a stream stage to measure every 5 minutes. You may schedule a wind sensor to be measured every 5 seconds. You may schedule a water quality measurement to happen every hour. And all of these things, SatLink measures them on that schedule and does again the additional calculations and stores the data into memory. Then at some point, it comes time to transmit the data, and SatLink accepts a user-entered schedule, and that particular schedule, when that time comes along, SatLink will format the data and transmit it back to the central location. SatLink can also make a transmission based upon alarms. So if you have a critical measurement that you want to make, and you know that if that data is in alarm, if it grows greater than, let's say, 5 feet, you program that alarm into SatLink, and as soon as that measurement goes over 5 feet, there's an alarm transmission made. In addition to its data collection, it's always monitoring its own internal status, doing its own diagnostic checks, and recording this information too, and also making this information available for transmission. So along with the data, you can have this metadata of how well the station is operating and get an advanced look at whether or not there's any problems with your battery or your solar panel or anything that's going on in the system. So really what sets SatLink, the whole SatLink line apart from earlier models and the competition is really our communications programs. The LinkComm version 3 is what we call a common communicator program. What that means is that LinkComm can connect to SatLink 3 via several different means, via Wi-Fi, RS-232, or USB. It's used to do the main functions that you want to with the station, including set it up, view live readings, download data, view diagnostics, and calibrate sensors. And it works with all the major kinds of devices that you'll have out in the field, including iPads, iPhones, Android, mobile devices, and a variety of Windows, XP 7, 8, and 9 laptops and PCs. What's nice about the LinkComm program is that once you've learned to use it on any of those devices, you'll be comfortable using it on one of the other ones. The program scales itself to operate on any of the devices that we list there, and it makes it so that once you've learned it in one place, you'll be very comfortable using it on any other device. LinkComm is very easy to install on your device. You can download it either from Google Play or iTunes and install it as you would any other app, or you can go to Sutron.com and download it from Sutron's product pages. Just one note, it does run on all versions of Windows 7, 8, 9, 10. If you are running Windows 7, you will need to install some USB drivers. These drivers aren't needed for the later versions of Windows. I encourage you all to download it, try it out, but right now we're going to shift gears and demonstrate LinkComm and its use with the SatLink 3. So here we go. I've got LinkComm installed on my computer, and I'm going to go ahead and run it. And when LinkComm runs, it gives you the main station page to begin with. Here's where I would, if I were connecting to a station, select the station type, select what kind of connection I was going to make, whether it was USB, serial, Wi-Fi, TCP, or modem. And then finally, I would hit connect. LinkComm also has a great offline mode that allows you to work even if you don't have a device. So what we'd like to do during this live demo is to take you to a field station. We'll go to a station that's called Lone Creek, and our job will be as the field tech to visit the station, to calibrate the river stage sensor, to check the other sensors that are connected, to check the status of the system, and also to connect a new precipitation sensor. So as soon as we visit the site, get to the site, we would connect our USB cable to the OTG connection, verify that we've set USB and the right device, and hit connect. As soon as we hit connect, we're brought to the dashboard tab of LinkComm. And the dashboard tab gives you a summary of all the sensors that are being measured, the telemetry that's happening, the system status, and it even gives you a view of what the data look like for the last 7 days. So I have a good idea that the station's been working quite well. There are no errors. It has the gauge height and water temperature enabled that I thought were at the station, and it looks like the transmitter is having no problems. So let's get to our task. We'll go to the Measurements tab, and we can see again the gauge height and water temperature sensors. My first task is to go in and calibrate the gauge sensor. We do that by using the Calibrate button. Before I do, let me just show you some of the things that are in the Measurements tab. We can support, as I mentioned, 32 measurements. You see most of them are grayed out. We only have 2 that have been enabled. They're labeled M1 through M32. The label shows up along with the measurement interval. On the right-hand side, we see that there's lots of information very easily accessible for each measurement. Here's the sensor information, the configuration, where I specify things that are specific to the sensor being measured. Here's the measurement schedule, the processing, alarms, logging, and transmission content. So it's all in one place, all the information. You don't have to remember anything. You can just very easily scroll to what you want to view or change and work with it there. So we're coming in here to calibrate, so I'll go to the processing section. And if I were to look at my staff gauge and see that the current reading was 2.48, I would hit calibrate, enter 2.48, click OK. The system goes out, performs another measurement, and does the calibration. Force another measurement, and it's 2.48. So it's calibrated to exactly match the staff gauge. I also have the ability to do a live poll And live poll is kind of nice because it repeatedly makes that measurement and displays it for you. So you can see I'm right now at 2.48. It takes about 5 or 6 seconds to make this stream gauge sensor. It's measuring a bubbler, and you can see that it's making repeated measurements. Water's changing on us here a little bit. That's okay. That does that. And I hit stop. Let's look while we're here at the water temperature sensor. I just click on here and you see it suddenly changed. Now I'm measuring the water temperature, the gauge height, water temperature. It just keeps everything in the same position. It's currently at 24.2 degrees. Let's go into a live poll for it. Hit start. And you can see it's making repeated measurements of the water temperature. This again is an STI sensor. All right, let's take a little closer look at some of these settings. We can see that the gauge height is an STI 12 sensor, and the water temperature is also an STI 12 sensor. I can see the wiring of how it's wired. I've got each of these sensors set up to measure every 15 minutes. I don't have any alarm processing turned on for them. I'm going to log every value that's measured, and I'm going to transmit all the data that's logged. Let's go over to the telemetry section for just a minute. Here you can see is where we've configured the satellite transmitter to work. Again, it's a great view of all the settings that are necessary for the transmission. There's the option for the antenna, and you'll notice that as you change the antenna selection, the output power changes. The Yagi with the highest gain is the most power efficient. You only need to transmit with 1.25 watts. An Omni, you need 7 watts. Over here we see the telemetry status. This gives you a great view of what the transmitter has been doing since it's been turned on. And you can see here the time of the next transmission, as well as a view of how many transmissions it's made since someone pressed clear counts. There's a great diagnostics of measuring the battery before, during, and at the end of the transmission. That's really useful for identifying batteries that are starting to lose capacity. Over here, Show TX Data is a really cool tool that we have. It tells me what my last transmission looked like, and if I were to transmit right now, what it would look like. And here you can see there's the gauge height, and there's 4 of them in there, 2, 3, 4, and the water temperature, 1, 2, 3, 4. It's also appending a loaded battery and appending the station name to the end. All this is summarized, saying that the message is going to be 86 bytes long, which is 4 seconds out of your 10-second window, which would be 343 bytes. And we have this antenna aim feature that allows you to select which satellite you're going to, the east or west. And then, since it has a GPS, it knows its location. It uses that in order to compute what your azimuth and elevation is. And you can see here we're going to be aiming our antenna 180 degrees and 45 degrees elevation. While we're talking about GPS, the GPS receiver, we have a nice graph for it showing all the satellites that it can currently see. If we refresh this, you'll see the numbers change a bit because those satellites are always moving, and you have a clear view right now that this unit is able to see all the GPS satellites. In fact, you only need to see 3 in order to do an accurate time sync. Some of the details of what's the GPS receiver and how well it's working are included up here. So let's get back to our task. Our job when we're visiting the station was to add a precipitation sensor. So let's go in and go to M3 and enable it. We're going to go to the sensor template and select the rain gauge. Up pops my rain gauge. I hit select. And now the unit has done all the configuration needed for my rain gauge. I just need to go in and check the settings, which we'll do right now. So it says I've got a rain gauge. It's a Sutron rain gauge and is giving some metadata associated with it. I'm going to use 2 right digits of precision. Here it shows me how I will wire to the rain gauge to pins 9 and 10 to ground and TB/DIN number 2. It's set to measure every hour. I don't want that. I'll come in here and set it to measure every 15 minutes. And the next thing we do then is to notice that as soon as we started making changes, the indicator here shows you that LinkComm is no longer in sync with what the setup is in SatLink. So I'm going to hit the change button. Click yes. And now we're all in sync. So the next thing we have to do is to test out that tipping bucket to see how it's working. So let's go in and force a measurement. And we see that it's not read any precip. Notice that our slope is 0.01, which is right for our tipping bucket. We're going to tip the tipping bucket a couple times manually. Force the measurement, and we see that it's counting each of the tips and working properly. Let's not leave it at 0.06. Let's reset it back to 0. So just hit that calibration button. And we're good to go. So now we have our 3 sensors, our gauge height, water temperature, and rain accumulation. For all of them, looking at the data, it's going to transmit all of the logged data. And you can see that precip accumulation requires no additional configuration. Some of these other sensors did. So let's go to the telemetry section and see how our transmission has changed. Let's show the TX data. And now we see, while we used to transmit with just gauge height and water temperature, we now add in rain accumulation. And we say, oh, that's not right. I've got to change the label for that sensor. So let's go in and come back to the system, change it to PR or whatever my code is for it. Send the changes, and we're good. One of the nice things, let's say that I change this to 3. You can see any change that you're making by clicking on that yes box when it asks you, do you want to see view the differences? And it's saying that your new setting is 3, your old setting is 2, gives you great detail of what you're going to change. I'm going to say no. Change this back to 2. Notice we're back in sync. All right, go back to telemetry, show TX data. Now we've got the right label, PR for the precipitation, and everything looks good. Once we're done working with the station and it's time to go, we normally would just hit the disconnect button. So let's disconnect, and up pops what we call our scorecard or quick status. This gives you a view at a glance of anything that needs attention before you leave the station. It's saying there are currently no errors, the station is recording, tells you how many measurements are active and how many are being transmitted by the different transmission routines, and it shows that both transmissions are enabled. So the scorecard gives you great confidence that you can leave the site, you're going to leave it operating, and everything's going to be perfect. Let's go back though for a minute, return to the setup. Let's go ahead and disconnect my GPS antenna for a minute. Refresh status, we see, oh, GPS antennas. Let's say I didn't notice that and I hit on my disconnect. There you see it prominently saying GPS antenna not connected. Normally you'll want to return to setup, correct the error before you exit. And there we go. So that shows you how we operate with a station. If I come back to the station menu, the system knows that I've been working on Lone Creek and it says, do you want to save this in your station list? I hit yes, and now we have Lone Creek in our list for when we visit it the next time. So let me show you a couple other things. I've told you that we have a responsive design built into the system, so this is what it would look like on a PC or many tablets, but if I were working on an iPhone, this might be the view that I have of the station. I hit connect again. It's giving me everything just like before. Measurements. It's giving me the details of that measurement. All very accessible. If that's measurement 1, if I want to look at measurement 2, measurement 3, measurement 1, and look at my transmitter, and so forth. So you get the idea. Once you've learned the program, you're not going to have any problem using it on a different size device. So now let's connect via Wi-Fi and see how that works. So if instead I wanted to connect via Wi-Fi, one of the first things I have to do is to navigate in my system to the Wi-Fi settings and select the Wi-Fi connection or hotspot that I want to work with. So here I found SL3 Lone Creek, the station. I've got a lot of other stations here at Sutron, but let's select this Lone Creek and let's say yes, I want to connect automatically to it. Come over here and select station Wi-Fi, hit connect, and now I've connected via Wi-Fi. So this is great if you want to be in your truck while you're operating the station. You can certainly go there to get out of the elements. You can hold the display in your hand. You don't have to be tethered to the unit. You can be nearby. Wi-Fi really makes it easy to work with the station. One of the things I didn't show you is the data tab. By default, the unit captures the last 7 days of data, and here on the tab I get to see it graphically in more detail than you could on the dashboard. So here, for example, I can zoom in on any particular section. I can double click and zoom out. Here I'm going to zoom in on the water level. I have hovering ability, so I can tell the data was 2.27 at 1845. I can, if I want, download more data, the past month, the past 6 months, the whole log. And downloads happen very quickly. It takes about 5 minutes to download the entire log of a SatLink 3, and that's over 1 million readings. We have a couple other really great tools to help people. One is in the diagnostics, the Save Diagnostics to a file. When I click on Save Diagnostics, the system's going to read the setup. It's going to read data from the log. It's going to read the last data and save the information. And I just click Save. It also gives you the option to email this to Sutron customer service. So now what we're going to do, we've discussed the scenario of the person visiting an existing station. Now let's look at how hard it is to create that station ourselves. So what we're going to do is over here in this section, we're going to set the unit back to factory defaults. And now we see that there's no sensors enabled in the system. So the first thing to do, come to the measurements and let's enable our stream sensor. So let's enable it, go to the sensor template. Let's just reduce this list a bit and look at just Sutron sensors. I can either scroll through and find the sensor, my constant flow bubbler, or use it in the drop-down list. I find the sensor I want. Let's hit select. And there I've configured the constant flow bubbler. Now all I have to do is go through the settings and configuration to make sure I'm happy with those defaults that came with the template. See right away, no, I don't want 3 right digits, I want 2. I'm going to connect this to SDI port number 1, and here's the wiring for how you connect a Sutron bubbler to the unit. The M6 command allows you to get both gauge height and temperature, so you may be used to using just the M command, but we're going to use M6 in this example. And the measurement interval is great, what we want. So let's go ahead and force a measurement. It says, oh, hey, you've changed the setup. Do you want to send it before forcing the measurement? Yes, I do. So I'm going to force the measurement. And there I see 2.41. So I know, great, I'm working just fine. Notice it says recording's off here. If we're going to make lots of changes to the system, it's nice to have recording off because then it doesn't try and do something that you've only set up halfway. But it'll still work either way. Let's look and see about the telemetry. It's set to log all the data it measures. That's fine. It's measuring every 15 minutes. It's going to log it all, and it's going to transmit all the log data. Let's go in and change our label here to the standard chef code for it, HG. All right, so now let's set up the precipitation sensor, excuse me, the water temperature. So we'll come in and we will again enable it, use our template. Let's find the aqua temp. There it is. Select it, configure, and there we've got the water temp. Now notice it is also going to use port 1. I actually had it connected to port 2 just so I could show you that you can have SDI address 0 on port 1 and an SDI address 0 on port 2, and they don't interfere with each other. I can look and see how it gets wired. Measurement interval 15 minutes again. Let's sync up. Force the measurement. There we are, 24.40. It's that easy to set up those measurements. Let's go into telemetry. I'm going to enable the self-time transmissions. I enter my scheduled time the way it's been given to me. Perhaps it's 0, 0, :45, :10. And transmit every hour. Window length 10. Goes 300, yes. Put in my goes ID. Put in my channel. Select whether I want to transmit in chef format or pseudo-binary format. Let's leave it at chef. Pick my antenna. Decide if I'm going to append any data to the end of the transmission, like that battery voltage. And send the setup over. Let's look and see what we're changing now. You can see we're changing the append, enable, the output power, the ID, and a few other changes. There it is. If I wanted to see what the transmission data would look like right now, HG, temp, and BL. I don't want to say temp there. I want to change that label. So let's go back to measurements. WT. Okay, while we're at it, let's start recording. So we'll just push it again, start recording, and now we've got the green in sync check. So it's that easy to set up a SatLink 3. Let's go ahead and do our disconnect. You can see in this case, I've set it up for no errors in the setup. It's recording, 2 measurements are active with 2 transmitted. Enabled, but I haven't enabled any random transmissions yet. Let's go ahead and enable the random transmissions. We're going to transmit randomly every 12 hours or every 12 hours if there are no problems, and every hour if it's an alarm. I've got to enter my channel. I'm going to leave it at 195, but that's not a random channel. Random format pseudo-binary. And here you see what the random transmission would look like. It's 11 bytes. You're only given 81 total bytes for your random transmission. Now those random transmissions will go, but I haven't configured any alarms yet. So let's go in and configure an alarm that says, well, let's say with the gauge height goes above 2.6 feet. Then I'm going to transmit the data in alarm both when I go in to alarm and out of alarm. And there we see. Scheduled transmissions are enabled, random transmissions are enabled. The next random transmission will be tomorrow or tonight at midnight, close to it. Now we're all set. Let's return to the setup because there are a few more things I want to show you. The sensor template, as we discussed, is fairly rich with lots of different models of sensors. We have some generic sensors. Here's just like a counter. Here's a 4 to 20 milliamp sensor. There's our bubbler, a frequency input, water quality sensors, pyranometers, wind speed direction sensors, bubblers, submersible. The templates are there because we've predefined and taken the most common settings that you would use in setting up that sensor. Let's say, for example, though, that you don't have one of those sensors in your template. For me to create my own sensor that's not in the template, it's very easy. I just enable, and instead of selecting template, I select the measurement type. Is it an analog sensor? Is it a digital sensor? Is it an internal sensor? What kind of sensor is it? Let's assume it's analog for a moment. As soon as I pick analog, the configuration information down here changes, and it says, well, what kind of analog do you have? Is it 0.5 volt or is it a differential sensor? Let's say it's a differential. And you see the idea of how you wire to it is shown in the wiring diagram. I'd still then do my only other settings, which is to set up the schedule. I'd force a measurement of that particular input, and I'd experiment with the sensor to make sure that it was reading accurately. So that's all there is to it. If you look at the digital sensors, you have a choice of level inputs and frequencies or counters and so forth. Internal temperature is great because it allows us to track and log the internal temperature measurement, which is nice to know what the conditions are inside the cabinet where the unit's located. So that's all there is to configuring your own sensor. You've got to know a few of the details about the sensor itself, but we help you as much as possible by giving you suggested wiring diagrams for it. Let's do one other thing associated with this site. What we're going to do is come up to the File menu here and say Export Setup. As soon as I do, it's going to say it wants to create a file called Lone Creek _setup and then today's date. And if I hit Save, I've now saved all the details associated with this station setup. At a later time, I could come and do an import setup and import that same setup from Lone Creek and preserve all the settings. Or I could read in from a different station. Here, let's import the setup from this wind test setup that I have. And now you see there's a bunch of sensors that are configured for the unit. So you can save setups by exporting them and re-importing them. So that's it for our demo of LinkComm. We think if you're a current SatLink 2 user, you'll find SatLink 3 more powerful and easier to use than ever before. If you're not a SatLink user, we hope you'll give it a try. The built-in features allow SatLink to handle the most demanding field applications. All right, with that, see if there's anything that, any questions that we have or anything else people want to see me demonstrate.
Yeah, absolutely. We've got a few questions here. First one is from Scott. Can I use SatLink Communicator to communicate with SatLink 3?
No, you would not use SatLink Communicator. So for those who don't know what SatLink Communicator is, that's Sutron's older Windows-based program for talking to SatLink 2s. And that communicator program does not know about SatLink 3. The reason you don't need it is because LinkComm really is an improvement of that SatLink communicator program, and it will work with any SatLink 3, and hopefully in the future it will also work with your older SatLink 2s, but for the meantime Use SatLink Communicator for SatLink 2s and LinkComm for SatLink 3s.
All right, next question is from Clarence. What is the purpose and capabilities of the USB slot, and how does this work with the enclosure version?
Great question. The USB, there are actually two USB connections. One's called OTG, on the go, and the other's called USB host. You're probably talking about USB host. That's where a memory stick plugs in. And the functionality is really cool there because you'll plug in a memory stick and the light around the Wi-Fi button will start flashing for about 5 or 6 seconds. It's going to be recording all the most recent data since the last time you downloaded data to that memory stick, along with the setup, along with some diagnostics. And it only takes 5 seconds, and you pull it out and you're ready to leave the site. It's a great way to capture the data from the station as well as the setup. And that's all done through the USB host. That other USB on the go is for connection to your PC. Now, when you're in the enclosure, the version with the display, that USB host connection is brought to the front panel. So you'll be able to do those same operations with the memory stick from the outside of the unit that you could as though you were talking directly to SatLink 3.
Very good. We'll take 2 more questions here. Next is from Fernando. What is the best way to ensure I am running the latest firmware for SatLink 3 and the latest software for LinkComm?
Well, I'll go ahead and answer that, Joe. We're really excited about this new product, the SatLink 3, and so what we've done is we've actually created a web page that you can actually go in and register for updates. And so we'll go ahead and provide this for you. That introduces the SatLink 3, and as you scroll down, you'll be able to put your name, your contact information. So anytime there's any updates in relation to the LinkComm software or the firmware upgrade on a SatLink 3, we will go ahead and contact you and let you know that there's available upgrades for either one of those. Also, anytime you can actually go to the Sutron webpage and go ahead and update the latest firmware as well. Just in the download section of the SatLink 3, we will have LinkComm listed there for you for any one of the versions depending on what you're actually using to connect to the SatLink 3. And so we'll have all those versions listed right there so you can download it at any time.
Right, and just to add a little bit to that, if you've downloaded the LinkComm from the Google Play or App Store, those version, whenever we put a new version out at Google Play or with iTunes, that should automatically upgrade to your software just as your other apps will want to upgrade. There are some settings that control whether or not that happens. You have control over it, but that's another nice feature. And along with LinkComm is built in the most recent update of the embedded software that goes in SatLink 3 itself, so that not only can you upgrade LinkComm, but then you'll be able to optionally upgrade your SatLink 3 software too.
Very good. All right, and last question from Jack. How far away can you be with your mobile device and still talk to the SatLink 3?
Great question. We've tested the device and it goes 100 feet in many situations. You know, inside a building you could have a little bit less performance, but most of the time if you're outside you'll be able to easily go 100 feet. It could go further, it could be a little less, but you'll be able to, hopefully that will be far enough that you don't have to be right in an uncomfortable situation. You might be able to stay in your car to operate the unit. You may be able to get out of the elements with that distance.
Dan, another thing that's been brought up actually with that 100-foot range is that this will allow a lot of the users to do flow measurements and be able to check their current stage readings. The section where you showed the live poll of the live readings, they could actually take live readings as they're doing flow measurements being within 100 feet of the gauge station. So it's another great feature of using that Wi-Fi connection.
Okay, great. Thanks, Brent.
All right, thanks again everybody for joining us today. If there are any questions that we didn't get to, we'll be emailing you. If you have any questions that come up later, here are some contact details for the presenters. Feel free to ask questions anytime. Thanks for joining us.
Thank you, everybody.